Hi everyone. I had a request for another video on graphing polynomials. Okay, so let's say we're given a polynomial f of x is equal to x minus 1 times x plus 1 times x minus 2 squared. Okay, so the very first thing that I like to do here, and this is a little bit different than the way Alex does it, but I think it's more intuitive for understanding what's going on here, is I like to first establish all of the zeros of this polynomial, okay? So the zeros, the zeros are as follows. So we have, looks like 1, we have -1, and we have 2. And we get that from each of the factors here, okay? So we have x minus 1, x plus 1, and x minus 2. So if you plugged in 1, for example, into x minus 1, or 1 minus 1 in this case, would be 0. So therefore, that would make all f of x 0. Same thing for the factor x plus 1 if you were to plug in x minus 1, and x minus 2 if you were to plug in x equals 2. Okay, so these are the zeros. And the first thing I like to do is I like to go ahead and just plot each of those points. So the zeros are going to be x equals 1, x equals -1, and x equals 2. So we'll do -1, looks like. We have 1, and we have 2. All right, so now that we have those, the next thing we need to do is we need to determine the leading term. Okay? And what this does is this comes from multiplying the leading term of all of the factors together. So what I like to do is I like to go ahead and write each factor out individually here. So we can actually rewrite f of x as x minus 1 times x plus 1 times x minus 2 times x minus 2. This comes because we're squaring x minus 2. So then I identify the leading term in each of the factors. So here we have x, 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 and x. And we're going to multiply all of those together. So we have x times x times x times x. And that's going to give us x to the fourth. Okay, so what we do with this is this helps us to determine the end behavior. The end behavior. Okay, and what end behavior means is it's just what happens to the graph as we go off to infinity and to negative infinity. Now, if you want details on exactly how to determine that, maybe go back and watch the previous video that I did on this, or go look at Alex, or go look at the textbooks. There's lots of charts that go over all of the different options. But here, since the leading term, the leading coefficient, or in this case, we just have an implied 1 here, that means it's positive, and the exponent is even, which is a 4, that means that the graph is going to rise to the right and fall, or I'm sorry, and rise as well to the left. So that means as we go off to infinity and off to negative infinity, the graph is going to go up. So we can go ahead and actually graph that. We can graph what happens as we go off to negative infinity and off to infinity. So let's go ahead and do that. So as we go to negative infinity, the graph is going to go up. And as we go to positive infinity, the graph is going to go up. So we have now found basically half the graph just right off the bat, or most of the graph, I guess I should say, right off the bat. Okay, we know that now we don't necessarily know how steep it's going to be, or exactly what all is going to happen there, or how it's going to go up or down. We just know that it's going to go off to infinity as we go to the right, and it's going to go off to infinity as we go to the left. That's all we know. Okay, so the next thing we need to do is we need to determine the behavior of the graph at each of the zeros. Okay, so let's do that now. And this comes by looking at the multiplicity of each of the zeros. So our zeros were 1. So let's label these here. Zeros are 1. They're -1. And it is 2. Okay, so this will be our multiplicity here. Okay, what this means is this is You can think of this as kind of like the number of times that the zero shows up. Okay. Um, so in this case, since we expanded it out to x minus one, x plus one, x minus two, and then again x minus two, you can think of how many times you see that zero. So we see the zero one from the factor x minus one. We only see that one time. So this has a multiplicity of one. Okay. We see the zero negative one time. So this also has a multiplicity of one. But we see the zero two as x minus 2, or from x minus 2, we see that twice. So it has a multiplicity of 2. So if the multiplicity, if the, let's write this out, the multiplicity is odd, okay, the graph will cross, the graph crosses at that zero, okay? So it's going to go through the zero, okay? The graph of the function is going to go through the zero. If the multiplicity is even, the graph touches but does not cross. So it will touch that zero, but it will not cross. So let's see how this applies for each of these zeros. So at the zero, let's start at the left here. At the zero negative one, we have a multiplicity of one, which is odd. Okay, so that means it's going to cross at that zero. Okay, so we can pretty safely go through that point. Okay, and we have to go back up to our next zero here, and we find out what's going to happen at that zero. So that's at the zero, 1, which also has an odd multiplicity. So we cross, okay, we cross at that zero. Okay, and we go back down our next zero, and if we did this right, this should touch but not cross. And this has an even multiplicity, so this is going to touch but not cross here, okay, just based on the rules we had here, and it's going to go back up to infinity. If you want to get really specific about this, what you can do is you can determine the y-intercept, okay? All right, so in order to determine the y-intercept, what we would do is we would plug in x equals 0. Okay, so this is where it's going to cross the y-axis. So to find the y-intercept, find f of 0. Now, I will say, if this were on my midterm, for example, or if I were to see this in the final, if I were to see this on the final, I would consider this to be good enough, unless it specifically asks you to graph the y-intercept, and then I would want you to obviously do that. But if you were to just say graph this polynomial, I would accept this right here. But if you want to make it even better, you can graph the y-intercept, okay? So you'll graph f of 0. So we have f of 0 is going to be 0 minus 1 times 0 plus 1 times 0 minus 2 squared. Or in other words, we'll have negative 1 times negative 2 squared. Okay? Which is going to be negative 1 times 4, or just 4. I'm sorry, negative 4. It'll be negative 4. So really, what we should do here is we could go ahead and plot another point here at negative 4. And we can connect the dots, I guess, kind of like that. All right, so this would be the basic shape of the graph if you want to be even more specific. So yeah, so this is and really you would do this no matter how complicated the function gets. All you have to do is find all of the zeros. You find the leading term and determine the graph's in behavior. and then at each of the zeros, you determine the multiplicity, and that's going to show you the behavior of each of or the behavior of the graph at each of the zeros. Okay, and if you want to get even more specific, you find the y-intercept. So these look really intimidating, but as long as you just remember these a few basic steps, it's really not that bad. So again, if you need any more help, if anybody needs any more specific help with this, please reach out. I'd be happy to maybe meet with you and try to help you out if you're still confused about what's going on here. It's okay if you are, but I can't help you if I don't know. So just reach out if you have any questions at all, and good luck studying for the final.